Hello, my name is Hector Vera, and this is the flashing LED circuit. It functions to have an LED flicker on and off. The materials I use for this project are a 1 microfarad capacitor, two 1000 ohm resistors, a 470,000 resistor, one LED, 9-volt battery with adapter, breadboard, 7 wire leads, and a 555 timer, most importantly, because this 555 timer has a lot of the mechanisms needed for this whole circuit to work. It is an integrated circuit, meaning it is a small circuit made on a semiconducting material. It has 3 modes, but the mode that is used in this project is the astable mode, which allows the 555 timer to produce an oscillating voltage necessary to have the LED flicker on and off. Here is a diagram of the labels for the 8 pins of a 555 timer. And here is the schematics for the circuit. We have the capacitor in series with the 470,000 ohm resistor and the 1000 ohm resistor. You have the 555 timer here with the components on the inside that illustrate how this works. The 1000 ohm resistor here and the LED. So inside the 555 timer, we have a voltage divider, which provides an input voltage to these devices here called comparators. This comparator receives 2/3 the original source voltage from the voltage divider, and this comparator receives 1/3 the source voltage. And these comparators serve to receive 2 different voltages at 2 different inputs, one labeled plus, one labeled minus, and it will then compare the voltages and produce an output based on which voltage is greater. If the voltage at the plus input is greater than the one at the minus input, then this comparator will produce a 1 output. But if the plus comparator is less than the voltage received by the minus comparator, this comparator will produce a 0 output. So the voltage divider provides voltage to this minus input and this plus input, while the capacitor provides an input voltage to the plus input here and the minus input down here. And when this circuit is closed, this capacitor starts to charge and bring voltage to these inputs. But because it's charging, it has a low voltage. Therefore, the plus input voltage here will be less than the voltage provided by the voltage divider. Meaning this comparator will produce a 0, while this one will produce a 1, because the 1/3 source voltage provided by the voltage divider will be greater than the voltage provided by the capacitor, meaning this will produce a 1. These outputs will be fed to the device called a flip-flop, which simply takes the outputs of the comparators and flips them. With this specific output produced by the flip-flop will cause this device here, called the output, to produce a voltage output, which will provide current to the LED and will also disable this transistor here. It'll turn it into an off switch, basically. However, this doesn't stay like this for very long, because once the capacitor charges up to full potential, then these outputs here will change from a 0 up here to a 1 up here, and from a 1 down here previously to a 0, which will produce different outputs by the flip-flop, and therefore cause the output here to disable, and it'll cause this transistor to act as a closed switch, meaning the capacitor will discharge, meaning it will reduce its voltage. Therefore, starting and causing this whole thing to go back to square one, where the capacitor has to once again charge up, and the cycle will repeat over again. This is how we get oscillation. Now, these resistors here function to control how the LED flickers on and off. As we can see by this equation here, the on time, which is the time that the LED will stay on, depends on the resistor 1, resistor 2, and the value of the capacitor. Meaning if we change the values of the resistors, we can change the on time of the LED. Here's an example. Here is the original 470,000 resistor being swapped for a 56,000 resistor. We'll see how it differs. It turns off and on much faster, as opposed to replacing this 470,000 ohm resistor with a 560,000 ohm resistor. It stays lit for longer. This project was easy to assemble. The hardest part came from learning about the 555 timer and exactly what goes on inside it to cause the voltage oscillation. But overall, it was an enjoyable project.